Hello class. This recording is on Chapter 11 of the ER book, Relational Mapping and Reverse Engineering of ER and EER diagrams. For this recording, I'd like you to bring your slides, get your slides in front of you, and have your textbook, your ER book in front of you. We're going to be using both. So what's the basic idea of this chapter? Well, so far this semester we have been learning how to create ER and EER diagrams. We've been learning how to conceptualize the real-world data in the form of ER diagrams. And then from ER diagrams we have been learning how to map the ER diagram to the relational database. Now, in this chapter, we are going to be learning how to do just the reverse. Hence, it's called reverse engineering. We will learn how to, from a set of relational tables, come up with the ER diagram. So, in the previous chapters, we had ER diagrams, and from ER diagrams, we were learning how to reverse engineer or we were learning how to get relational tables, and in this chapter we will go from relational tables to the ER diagrams. Sometimes when you go out and you work for companies, you may come up with, there may be scenarios where you have tons and tons of tables that you will be working with, but there is no documentation. It becomes very hard to figure out which table is related to which other table or other tables. So you'd want to do an ER diagram to kind of visualize the whole impact or the whole database. So that would be a reason for doing from the relational tables the ER diagram, to visualize the database or maybe to explain it to someone in a visual format. So hence this chapter is called Reverse Engineering. Okay. So I'm on slide 3. What is reverse engineering? Well, so far we designed an ER diagram and then mapped it to a relational database. But when you go to work, you may have a database which may be huge, and you and your teammates may not have an idea of what the database is about. So you will need to reverse map the tables in the database to an ER diagram to understand it. So that's what reverse engineering is all about. Okay. Now, before you can efficiently do reverse engineering, you really need to know the forward engineering, which is what we have been learning so far, is how to do the relational tables from the ER diagrams, the forward engineering. So what I have in the next few slides actually is a summary of your rules for forward engineering. Okay. So on slide 5, we have step 1, which is map strong entities to a new table, and then we have step 2, which is map weak entities, and then going on to the next slide, we have step 3, which is mapping binary end-to-end relationships, and then step 4, mapping binary one-to-one relationships, and so forth. If you use your text, your mapping rules are summarized on starting the bottom of page 287 and going all the way up to page 292. So page 287 to page 292, which is really the first few pages of your chapter 11, has all the mapping rules summarized, and they're put together in one place so you can quickly refer to the mapping rules if you want to. On the slides, I did not elaborate on the mapping rules for mapping the ER diagram part. I just kind of left it on as a simple generic mapping rule. Okay. So basically, your mapping rules are summarized in the first part of the slides as well as in the first part of the chapter. Now, so basically you cannot reverse engineer unless you know the mapping rules really well, and that's why I have them at the beginning of the chapter. Okay, now to start the reverse engineering process, let's go to slide 15, which says reverse mapping steps. And I'm going to ask you to read all the slides in between on your own. So, just like in the first mapping rule, you map strong entities in the forward engineering. In reverse engineering, the first thing is you look for strong entities. Okay, so at this point, I'm going to ask you to open up page 295 of your book and look at figure 11.1. Okay, so say for example we have the table called R with the attributes A, B, C, D, and E, and A is underlined, which means A is the primary key. Well, the table name would become the strong entity, and its attributes would become the attributes of the table, and the primary key is underlined, so you would end up with figure 11.1. Okay, so this is how you would map strong entities. Basically, the name of your table would be the strong entity, and then you would have your attributes. Okay, the next mapping rule is you would look for the relationship. So how would we reverse engineer, say for example, one-to-n relationships? If you look at the bottom of page 295, we have two tables. A table called items with item number, description, price, and order number. And then we have a table called order number with order number, date, and customer number. Okay, I just noticed a slight typo here. Item number should be underlined and not description on items. Okay, so from these two tables, we can clearly see that we have a table. We have a table called items, which would translate into an entity, items, and you have a table called order, which would translate into the entity order. You have the primary key, which for items would be item number. Again, note that there was a typo, and description should not be underlined. It should be item number. And you have the other attributes, description, price, and order number. Then you have another entity, order, and you have the attributes, order number being the primary key, date, and customer number. But note that order number is the primary key of order, but it is also in items. So order number is probably the foreign key of items. So there's probably a one-to-n relationship from order to items. So in a one-to-n relationship, you typically take the key from the one side and put it on the n side. So we took it from the one side, which is order, and put it on the n side, which is items. So if you look at page 297, you'll see the ER diagram for the tables that are shown on the bottom of page 295. And so you'll see the table called item, the table called order. You'll see you'll see item number underlined for item, description and price, and then order number underlined for order, date, and customer number. So that would be reverse engineering relationships. How do you know that there is a relationship between one entity and another? Well, when the key of one entity is sitting in another, when the key of one table is sitting in another table as a foreign key, there probably is a relationship between the two tables. And that's how you determine relationships. Okay, now moving on, I'm going to kind of let you read your slides on your own. And at this point, I'm going to kind of follow the book here. And if you look at the bottom of page 298 now, and Okay, so we talked about relationships. The next thing would be trying to figure out if there are weak entities in a relationship, or if they're weak entities. How would you determine if they're weak entities? Well, if you see the primary key of a table sitting in another table as the primary key, and there is another primary key, then it is probably a weak entity. So you would determine if something is a weak entity if there's a primary key of one table sitting in another table. So for example, if you look at the bottom of page 298, you see the table called skill, which has employee number as the primary key and skill type as also the primary key, and date certified on it also. So because employee number is not its own primary key, but skill type is, you figure that this is a weak entity. And you know it's a weak entity because there is another attribute or more attributes besides just the keys. Versus, if you look at page 300, at the bottom of page 300, where we are checking for multi-valued attributes, look at the instructor table at the bottom of page 300. You have SSNO underlined and degree underlined. Well, in this case, this is a multi-valued attribute because you would suspect this is a multi-valued attribute because the primary key of instructor is SSNO, and it's in this table, and degree is in the table also. But there is no other attribute. If there were some other attribute, then you would suspect that this could be a weak entity. But since there's no other attribute attached to it, we are suspecting that this is probably a multi-valued attribute. Okay, how would we determine for the end-to-end relationship? Okay, let's look at page 303. And say, for example, we have a table called purchase with vendor number and part number. And when we see that vendor number is really the primary key on a table and part number is the primary key on a different table, but the two keys are together in the same table, then it's probably an end-to-end relationship. The price being on that table would make it an attribute on the relationship. So that's how we would determine that this is an end-to-end relationship. Okay, looking for the n-ary case. Well, very, very similar to the one we just discussed. When we see that we have a table that has the primary keys of all three different tables, one has the vendor number, one has the part number, and one has the customer number, but it's all in one table, all underlined, it's probably a multi-valued, sorry, not multi-valued, it's probably a ternary relationship with the three entities related. And price is probably on the relationship. Okay, now for mapping generalizations and specializations. How would you determine it's a generalization or a specialization kind of relationship? Well, if you look at the tables on top of page 305, you'll notice that table M has M underlined and then A, B, C, and F. Table N also has M underlined. Table O also has M underlined. Table P also has M underlined. If so many tables have the same primary key, it's probably an overlap or disjoint relationship. It's probably a generalization, specialization relationship. It's not a strong weak relationship because if it were a strong weak relationship, the weak entity would have two attributes underlined, its own and the key of the owner. But here there's only the primary key coming in from the owner, so we do suspect that this is a generalization, specialization case rather than a strong weak relationship. Now I'm going to let you kind of read the details on page 306 here and get a summary for the rest of it. But this is really the gist of the chapter. Okay, so basically what you have to know is really the forward engineering rules really well. And once you know the forward engineering rules, you should really be able to backward or reverse engineer with absolutely no problem, because you're just really reversing the rules in order to get the reverse engineering. Okay, and there might be some cases which are once in a while fuzzy. Like, for example, you might not for sure be able to say whether it's a one-to-one or one-to-n relationship at sometimes unless you have more information. But most of the time, you can deduce of whether it's, you can deduce the relationship, and although you might not be able to get it 100%, you can come very close to what the ER diagram should be from the relational mapping. Once in a while, you might need the help of data, because, for example, how would you determine whether for sure something is a one-to-one or a one-to-n? If you see more than one occurrence, then it's a one-to-n relationship. If there's always a one-to-one occurrence between the two tables, then it's a one-to-one kind of relationship. So once in a while, the data will also help you with the reverse engineering process. Okay, I hope this helps you better understand the reverse engineering process. I try to go as slow as possible. If you need to hear the slide over again, if you need to hear this Elluminate recording over again, make sure you just play it over again and read the chapter basically. I think I'll end here for now, and bye.